Hello everyone. Today we will solve a resultant problem. Here the problem states in figure 9 let f equals 3600 pound and theta equals 15 degree. Assume both pulleys to have no friction so that the tension in the cable CD is 3600 pound. Solve graphically for the force on the shaft at B. Solve graphically for the force on the bearing at A. Check each solution algebraically. So here the angle theta equals 15 degree. For the A part, let's draw a free body diagram for the B shaft. FBD. So it would look like something like this. Here the axis is, and then the angled one, which is the cable, and the vertical one, which is the F. In the question, F equals 3600 pound. So we will write just that, 3600 pound. And here the CD, which is 3600 pound also. So we will write 3600 pound. Here this angle equals 15 degree. So we can assume the whole angle as alpha, and let's think the resultant would be in this direction, and the angle it would make with the vertical axis would be theta 1. For that, let's find out the value of resultant or the magnitude of the resultant. For that, we will use R equals root over F1 square plus F2 square plus 2 into F1 F2 cos alpha. Then let's put the values here. For the F1, we can assume it as the vertical one, so it would be 3600 square plus the other one is also 3600 plus 2 into 3600 into 3600 cos, it would be 15 and 90, so it would be 105 degree. We can calculate it here to double check. It would be 15 plus 90, it would be 105. So let's write just that, 105, and let's calculate the values here. We will get 3600 square plus 3600 square plus 2 into 3600 into 3600 into cos 105, and then root over answer. Then we get 4383.08 pound. And if we try to find out the angle of it, then we will write theta 1 equals tan inverse F2 sine alpha divided by f1 plus f2 cos alpha. Then we will get tan inverse. For f2 we will take the CD or the tension in the cord. Then we will get 3600 sine 105, and then for f1 we will take the vertical one, which is 3600 plus f2, which is also 3600, then cos 105. Then we will get 3600 sine 105 divided by 3600 plus 3600 into cos 105, and then we will find out the tan inverse into answer. Then we will get 52.5 degree. 52.5 degree. So it would be the angle from the vertical axis to the resultant, or if you want to find it as the from the first quadrant, then we will have to subtract it from the 270 degree. So we will get 217.5. So it would be from the first quadrant, and this is the angle from the vertical axis. Let's solve the A shaft. So for that we will have to draw the free body diagram of it. So it would be the number 2 or the B part. So here the free body diagram would look something like this. Here the vertical one is 5000 pound, and there is an angled one which goes to the B shaft, and here is an angle of theta which is 15 degree, and the tension in the cord was 3600 pound. So let's assume the vertical one as f1 and the other f2. Let's find the magnitude of the resultant, which would come from here, somewhere along this line. Then let's assume the angle between those two forces as alpha. So the value of alpha would be 90 minus 15, which would be 75. Okay, for that let's apply the formula of R or resultant. We will get f1 square plus f2 square plus 2 into f1 into f2 cos alpha, and let's apply the values here. We will get 5000 square plus 3600 square plus 2 into 5000 into 3600 into cos 75. Then we will get 5000 square plus 3600 square plus 2 into 5000 into 3600 into cos 75, and then we will put a root over that answer. We will get 6,875. 6,875.86 pound. This would be the value of resultant, or the magnitude of the resultant. And then let's find out the theta 1, or the angle from the vertical axis to the resultant. So it would be theta 1 tan inverse f1, it would be f2 sine alpha divided by f1 plus f2 cos alpha, and let's put the values here. Then we will get f2, which was 3600 sine 75 degree divided by 5000 plus 3600 cos 75 degree. Then we will get 3600 into sine 75 divided by 5000 plus 3600 into cos 75, and then we will put the answer with the tan inverse. Then we will get the angle here, that would be 30.379, or we can say 30.338. 30.38 degree from the vertical axis. And if we think from the first quadrant, then we will have to add it with the 270 degree plus 30.38 degree. So it would be 338 degree. So it would be 300.38 degree. That's it for this math. Thanks for watching.